For this next video, we are going to talk about several different things, including intervals of increasing and decreasing, zeros and x-intercepts and y-intercepts of a function, domain and range, and end behavior. So looking at all three of these graphs in this picture, we're going to talk about the domain. The domain is all of your possible x values, and for all of these functions, we can actually choose anything we want on the x-axis. We are going to get some number. So your domain here is all real numbers. In fact, it's going to always be all real numbers unless we're talking about radicals, things that are square roots, like this. Then your domain is not all real numbers. Range is talking about all of your possible y values. And so looking at this function, because I've got an arrow that's going to increase forever and an arrow that's going to decrease forever, your range here is all real numbers. But for these, your range is going to start and stop at your vertex, right? So here, 4 and everything less than. So your range for this one is going to be y is less than or equal to 4. This one, also going to be less than or equal to, because it's pointing down, is going to be less than or equal to 4 again. This one is going to be all real numbers because we're talking about all of the y values. So it depends. Sometimes it's all real numbers. Sometimes it's going to be y is less than or equal to some number, and in this case it was 4. End behavior is talking about the ends of the graph, what's happening as your graph disappears off its page, right? What's happening as it's going off the paper. Well, these two are going to have the same end behavior. Notice they're both pointing down towards negative infinity. So both of these are approaching negative infinity to the left as x is getting closer, and to the right as x is getting bigger. So as your x is approaching negative infinity, your y is also approaching negative infinity. Same thing here, as x is approaching positive infinity, your y is pointing down, so it is approaching negative infinity. In this case, it's going to be doing two different things. As your x is getting closer towards negative infinity, your y is actually pointing up towards positive infinity. So in this case, as x is getting closer to negative infinity, your y is actually increasing towards positive infinity. As your x is getting bigger and going towards positive infinity, your y is actually pointing down towards negative infinity. So as x approaches positive infinity, your y, your function, is decreasing. It's going towards negative infinity. Now let's talk about intervals of increase and decrease. We're looking at our changing points. Where does this function change directions? It changes directions here. And so from negative infinity all the way to the number 1, we are going to be decreasing. Our function is coming down. So this is decreasing from negative infinity all the way to the negative 1. Now we start to increase, and we're going to increase until we hit positive 1. So this is an increasing. So from negative 1 to positive 1, we are increasing. Then we change again and we start decreasing again. So from 1 to positive infinity, we're going to be decreasing again. The absolute value and the quadratic here are also easy to find. They just have one turning point, and so those are a little easier. Here we're increasing from negative infinity all the way to negative 2. This would be increasing. And then, sorry, you can't see it. Here, from negative 2 to positive infinity, this is decreasing. Let's talk about x-intercepts and y-intercepts. X-intercepts are where your graph crosses the x-axis. So in this first one, we have an x-intercept at negative 1 and at positive 2. So your x-intercepts, negative 1, 0, and 2, 0. Your y-intercepts are where it crosses the y-axis, which is right here at 0, 2. Now, your zeros are actually the same thing as your x-intercepts. That's where your x is going to equal negative 1 and a 2. Those are zeros. Those are also the same thing as solutions, or if you see the word roots.